YouTubers, the constant reminder, never buy a Tesla product. So here we are. This is the final version of what I'm doing with my wind turbine, period. This is a Right tower. It's 5 sections, 50 feet. The last section where the platform is, and then the pipe going up, is 5 feet. So the wind turbine sitting at 55 feet above the ground. There is 2 guide wires from the front going to the ground, and then the pulley system acts as the 3rd one behind. It goes to the 40-foot section. I'll pinch in on that in a second to give you a shot of that. Right in there, you can possibly see it right in there. You'll see it from behind when I get there, right in the middle there, somewhere. If I can get my finger right in there, the 40-foot section. That's where the cables go for the pulley system. Otherwise, that is at 55 feet total. That is a HY or HEY or HYE high energy 1500L and 96 volt version. So that's going. It's actually already turned the inverter on. It's up there. So anerometer, of course, that's right just shy of the 50-foot mark. So that'll give me some good readings for what's coming across the hills here in the trees. So like I said, that's 55 feet. It's definitely clearing all those. It will not clear the winds coming off of those trees at 110 feet. This is at 35 feet, so it's well clear of that now. I did eliminate 1 tree out there in the corner. My neighbor's actually trimming some of these back, and we'll take some, topping them off some later on. So, the concern for one of the YouTubers out there in India. So, this is a Right 55 series, 40 feet, freestanding, category 2 hurricane, 117 miles an hour, with no guide wires. Above that, they tell you to put guide wires on it. I did 3/2 with a pulley system in the back, which definitely represents a pulley guide wire. So that would take it up to 50 meters for the wind turbine. That's where its survival rate is, at 50 meters a second, which is 111 miles an hour. So hopefully I never run into that anytime soon. So that's what we have. Did the tilt plate. I actually used a vehicle hoist motor, AC one, to basically get the tower up, because it is, I can hand crank it, but my little kids can't. So I was having them give me a hand cranking it. So what I did was, I have to get some more cable clamps. I only have 2 on each of these going down there, and these are not that tight. They have still a little bit of wobble. I'm gonna put more tension on it after I put the 3rd clamp on the cables here. Don't buy the ones off Amazon. They are not 1/4 inch rated. They are these cheapo ones, and they keep making them smaller. They say they're for 1/4 inch. They're not. These are cheapo, 8mm, and they do, you can actually strip them with a socket. So do not buy the cheap Amazon ones. Go to your local hardware store and get it. As before, I have the Class 8 hardened bolts. This time I actually did tighten them down, and those plates are welded in place, so they're not going to squeeze together. So that gives a little bit of gap in there for this plate. When it comes down, it's sort of like a wedge. So when it sits in there, it hits the bottom. Again, 3-phase AC goes through there. Conduit 18 inches down on the ground, across into the inverter. That's it for the tower. And then I said, like, this one is the backside. This is rated at 1,500 pounds of pull to lift. And then you guys saw that I made this little rig for a gen pole, since I am only 2 feet off the property line, so I didn't have any play area to go back and do all that stuff. See if I can get a shot without the sun here. And right up the pole, and that's the pulleys up there. As you can see, there's multiple lines there. That's the 1/4 inch cable. It's only rated for 8,600 pounds. That's what the book says finally. So then I have, like I said, 2 guide wires, one going over there on that side of the beehive, down to the same thing, 5-gallon bucket with a eye bolt stuck in it, 4-foot eye bolt, and it's buried all the way to the eye bolt, to the ground, galvanized, and then the cable's going back up. So that's it. Added 2 more sections of the tower, put the PVC in, resoldered everything, wired it. Later on, I'll get a video from up top, give you guys a panoramic view of the whole area from up top. As far as concerns, the guy in India wanted me to basically mention this. and I told him over-engineer it. I mean, this is 1-inch bar stock, which I know it's not going to flex. 3-inch I-beam, which is only 7 feet tall, and then welded with all that stuff on top. This is all welded to it. These are all rated at 6,000 pounds. That one I think is 9,000 pounds for that pulley, and that one's whatever 800, but that's only a roller bearing, so nothing really concerned about that thing. Even at 800 pounds, this whole thing assembled is 560, 600 and something, 105 a piece a section. So it's 5 sections, 525 pounds a tower from there going up. And then the wind turbine itself is, I think it's about 75 pounds. So it's whatever, 600 pounds. And then the pole and the welding that I did on the rods, just throwing in another 50 pounds on there. So there you have it. That's about it for now. He was worried about case safety concerns. I have this thing, like I said, over-engineered, definitely not going anywhere. This is a 28 by 28 concrete block under here. This goes down 72 inches. It's 1.2 yards of concrete. Brake force going either direction is 12,000, I'm gonna say 12,800 and something force to actually move. The base plate, they make these at a 1/4 inch. I made mine at a 1/2 inch. There was no way in heck, because the guy at the engineer said they will fail at a 1/4 inch. So this is 1/2 inch plate, hot galvanized. And the pegs that are in here, those are actually solid steel welded to the plate. So I actually beveled it back down to almost 1/3 its size and did welds, beveling it all the way around, and just kept going until I got it to the outer diameter and then stopped. So that is a solid peg in each one of those, just for strength. There's no way in hell that thing's snapping off that plate, or that plate's coming off the ground. So then we have 6 J-bolts that go down the 3 feet into this concrete, and all the J-bolts face. I had originally marked them when I was doing the things, and they had an arrow pointing this way, so I knew which way the J was. So when the thing's set in the concrete, they were all facing in. I don't know, facing in, facing out, I guess it doesn't really matter, but I didn't want these facing out at all, because that's right at the edge. It's only, a few inches from the edge. So that's there. Then these are, from 3/4, these are 1-inch J-bolts that go down 24 inches. This pad right here was a secondary, because I was getting flex from here to here on a 1/2 inch plate. This is a 1-inch steel plate welded on top of a 1/2 inch, so it's 1.5 inch steel with 1-inch J-bolts that go down 24 inches into this 1,200 pound hole of concrete, with J-bolts going into this original pour, coming out, and they're stuck out here, which actually connect to these J-bolts. I actually catch the little hooks together, and then I did the epoxy into this. So that's pulling this way up, this way over, and then with these 1-inch bars pressing that way, I don't get any flex, I don't get anything moving, so it's not going anywhere. This counterweights this, so their whole setup can be, what would you say, that's about a total of 5 feet from, that's 28, this is 28 inches, so 28 inches, and another, I forget whether this was 24, so 48 inches. So let's just say within a 5 foot pattern or footprint, you could have your whole tower assembly and hoist system right in there. So considerations for the guy in India: this thing's 55 feet. If it falls, we don't want it to hit my solar array, so that's one thing for consideration. So that's why the over-engineering and making sure this stays up no matter what. Catastrophe, it popped for some reason. Somebody came across the back fence here with a bulldozer and knocked it over. That thing is going to go forward, and it's going to smash right through my pool, right where that pole's sticking out of the top piece there, right where the poles are sticking over my pool. That's where it's going to hit, and it's going to rip right through the whole pool to the ground. So will not hit the house. That's one consideration. Don't go too high there. The other consideration, some people do, I don't even condone it in any way, having it attached to your house. So I don't need that kind of noise or vibration going through the house, or harmonic vibration starting on anything. So isolate it if you can, best you can, away from your structure if you have to, but that's it. My neighbors, if it falls that way, it doesn't hit any part of their house, their sheds or anything. This is the Barrow backyard. I don't think they're probably the ones that are going to be complaining about it, but hopefully not. guys are pretty cool. So otherwise it falls into nothing back here. The shed would stop it midway and actually stop it from going probably into the neighbor's yard on the other side, because it would have to hit somewhere in the solar panels here, crush those, and then fold and then go over on the top. It probably might hit the fence, I guess, at distance, be close, but it's not going to hit their house. They don't have anything in their backyard. So that one consideration. For the guy in India, he was talking about a vertical. As you guys all know, verticals are not that great. We do love them. They look great, but for production, absolutely worthless, unless you really want to waste money like I did and blow that. So we are suing Tessup in the small claims court. So that is still going through. Hopefully the courts rule in my favor and we actually get our money back for that piece of junk. So anyway, what else we got? Considerations. I never told my house insurance about this thing yet. I'll have to find out how they do for insuring wind turbines and structures like this, but I'm gonna let that slide for now. Like I said, now it's up there above the tree lines. It's constantly just spinning away, which is a nice sight. So stick away from the vertical for now. Just go with the horizontal, get your feet wet. Learning curve's been great. Tony from Hurricane Wind Power, shout out to him, who sold me this, and has been helping me along the way. We're working out the power curve to make sure this thing actually produces power for me. So the stronger winds are coming later this week. Definitely we'll see some power production there. In the meanwhile, it's just, you know, again, spin around, breaking in, I guess. So we'll get the real good weather here coming the end of September, going October, November, December. That's heavy winter winds, and that's where we should see some power. So, and at nighttime when the storms come through, so which will be nice. That's the only reason I got this thing, just to make some kind of power. As you know, I'm big into solar, have been since 2006. So, trying to think else, what else considerations. Money wasted, yeah, verticals not efficient as horizontals, as you guys all know. The guys out there that were asking about it, just start off with the horizontal, get your feet wet, like I said, get used to it, do something, and then if you want to switch to a horizontal or to a vertical, play with something small and then do something else. But I just say steer clear. They're still not, don't believe any of the manufacturer's ratings. That 2.5 meters startup speed, full crap. Yeah, it's great. It'll do exactly. It'll spin, but it won't do anything great. Everybody else can go out and watch Toys for Watts. He does a real good breakdown for guys who are doing battery banks and charging systems like that. This is a direct grid tie, so 3-phase AC. It goes down there. I'll show you the inside for all the rest of you guys that haven't seen this. I just finished doing the wiring and everything, so all the panels are back on. The shed's trashed right now. I have to put everything away. So it comes in 3-phase AC from the tower, goes in here, hooks up to its controls, and it's got the DC output, which comes over here, goes in here. This is the 240, 220, 240 lines going back over to my breaker box, temporary for now. I didn't do the conduit or the wire. This meter is really about pissing me off because it's supposed to show current power and the pins are pinned, but some reason it just goes offline by itself. I don't know if it's the inverter's kicking in, not enough power, but that thing's right now, it's only showing 21 volts at 0.1 amp. So not sure if that's even, it's not enough to put the inverter into a power production mode, but that's what it's doing right now. Just like you said, just seeing that thing spin up there is real small, but we'll see when the winds come in stronger. But in the meanwhile, I might have to send this back to the guys in California. They told me they tested out. There it is. They won't tap on it. It does have a battery symbol on there, but I don't think it's battery, because this thing says it keeps a memory for like 10 years, you know, unpowered. So boom, there it goes. So shake and wake, I don't know. Maybe it's not waking up, I don't know. So I'll have to find out more. I looked in the manual, didn't see anything. The guy says, you don't have braided wire. So I was like, you know what, hey, I'll put braided wire in there. I put braided wire, put the pins down there through them. So they're in there. It's not like they're not missing that wire. So, you know, I jerk on it. I don't know if it's the box or the things, but damn this thing doesn't piss me off. Now it's going to go watch. Zeros. Watch. Both lights out. All right, so Anyway, that's one of my hurdles. But anyway, those wires go strictly up to the 240. I think that's on a 40 amp, or no, 30 amp. 30 amp breaker. It goes up to a 30 amp breaker on that one for 240. So that's its max. So anyway, that's it for now. We're gonna call it quits for the day. I gotta get showered and I gotta go get some clamps for the cable. So that's about it. I'll keep you guys posted on the lawsuit against Tessup. We're trying to get those guys. Tessup Electronics LLC in the UK is the actual company name. 22 Sutton Lane North, London is their address. So if you look online, if you're going to sue Tessup for the money claims court, you got to have an address in the UK. So you have to actually hook up with somebody that's in the UK to actually do it to the courts. Otherwise, they tell you you have to have an address in the UK. So for some reason, you can't sue them outside the country. I don't know why, without an address. So that's where we're at with that for now. I'm working with a guy who lives there, so thank God I have an address there. And we'll keep you posted on the lawsuits against Tessup. So again, pass the word around. Never buy Tessup. I don't care what they're selling, even if they're selling the knockoff from InstaBreeze there in Turkey. Do not buy a Turkish product. They are trash. So anyway, that's it for now.